In this video, I will discuss offboarding for the Microsoft for Startups GPU cluster and next steps to take on Azure to deploy your model into your applications. As you approach the end of your 1 to 30-day reservation, if you're finished with your model training or batch inference, please delete your Azure ML compute cluster. This will release your quota back to the capacity pool and prevent non-sponsored compute costs. If you wish to cease all charges, then delete your resource group containing your Azure ML workspace and its dependent storage, key vault, and container resources as well. If you would like additional reservation time, please cancel any in-progress training jobs, but keep your Azure ML compute cluster. Your auto-scaling compute cluster will spin down and release your quota back to the capacity pool. Work with your account team to request additional sponsored reservation time. Once re-approved, you can spin up your same cluster up and resume training from your last checkpoint. With Azure, you have 60 plus regions, the most of any cloud provider, with many GPU accelerated VMs as well as compute or memory optimized CPU VMs for ongoing inference needs from providers such as NVIDIA, AMD, and Intel. B100s and T4s are great cost-effective starting points for inference where you need GPU acceleration for throughput and low latency. Consider the A10s for single GPU nodes as well. Look to NC A100s and NC H100s if you need larger GPU memory for large models such as the Llama family or Stable Diffusion. For real-time inference where you don't need a GPU, look at the compute optimized F-series SKUs such as the standard FAS V2. For batch inference where GPUs aren't required and to save costs, I'd recommend looking at the memory optimized D-series or M-series CPU instances and look to find a balance with horizontal scaling of smaller nodes. Raise an Azure support request for quota and work with your startup advisor, preferred sub at Microsoft.com for access and resource planning. There are two ways to deploy models in Azure Machine Learning post-training on the Microsoft for Startups GPU cluster as real-time HTTP endpoints and as batch inference pipelines. Real-time inference is useful when you're trying to perform inference on requests that come in one at a time while minimizing the time taken on individual requests. Batch inference is useful when you have a large quantity of data, for example, in a SQL database, and you want to perform inference on the whole data set as quickly as possible, but you don't care about the time taken to perform inference on an individual record. Serverless API endpoints are the newest option to consume large foundational models for real-time inferencing off the shelf or for fine-tuning such models in Azure. Not all models, including custom models, are available for deployment to serverless API endpoints yet, but it's an important option to consider if you're using the Microsoft for Startups GPU cluster compute for fine-tuning open source models such as Llama or supported Hugging Face models. The biggest benefit is Azure manages the underlying GPU infrastructure, so you just pay per token usage and don't have to worry about the individual GPU quota. Managed online endpoints are used to deploy your models in a turnkey manner across powerful computes like high-end CPUs and GPU machines in Azure in a scalable, fully managed manner without having to deal with the creation and administration of infrastructure. You can monitor their model availability, performance, and SLAs using out-of-the-box integration with Azure Monitor and Azure Log Analytics. Kubernetes endpoints enable you to deploy models to user-managed Kubernetes clusters for online scoring for your Azure Machine Learning workspace. Both managed compute online endpoints support local endpoints for dev tests to validate your model deployments on single node local compute. For batch inference, you can trigger these either through a batch endpoint, so a few changes to your scoring script, or through the Azure ML Pipelines SDK. As next steps on Azure, engage with your account team to review and discuss your Azure architecture plans. You can also get started faster building out your AI applications for your GPU cluster model by customizing one of the ACD templates of popular architecture patterns such as RAG and Copilot. I linked to the awesome ACD templates library on the slide to explore further. That concludes our video discussing offboarding for the Microsoft for Startups GPU cluster and available model hosting and inference services to take your next steps on Azure. In the next series of reference videos, I will demo several walkthroughs in the Azure portal to help you get started on the Microsoft for Startups GPU cluster.